if I were to come over to your place and say, name this molecule, the first thing you would do is you would say, well, look, we have a double bond. So we're dealing with an alkene. We have 4 carbons in the longest chain. There's actually one chain here. So it's 1, 2, 3, 4 carbons. So the prefix will be but. And regardless of which end you count from, the double bond starts at the number 2 carbon. So this is butene. Butene. I'd say, well, that's very good, and that is correct based on everything we've learned. But what about this molecule? What about the molecule that looks like this? The molecule that looks like this. And you'd go through the same process. You'd say it has a double bond. It's an alkene. Our longest chain has 4 carbons, 1, 2, 3, 4. Regardless of which end you start counting from, the double bond starts at the number 2 carbon, 1, 2, 3, 4. So once again, you'd say, hey, Sal, that's also butene. And then I'd point out that these are each fundamentally different molecules. And the reason why they're fundamentally different molecules is because this double bond can't rotate. It's got that pi bond there for that second bond that keeps this carbon-carbon bond rigid. So it's not like the molecule can switch configurations between this, or it's not like it can switch conformations between this and that. It cannot rotate around this double bond. So these are different molecules. These are different molecules. Different molecules that will behave different chemically. And because they behave different, we have to have different names for them. Now, there's 2 different naming conventions. One is kind of, I guess, the simpler naming convention. And it works when we have one functional group on each of the carbons in the double bond. And then in the next few videos, we'll talk about the slightly more advanced naming scheme that will work when we have more than one functional group. So the first way to name it is if you have your functional group. So let me circle the functional group. So in this top one, our functional groups are on opposite sides. They're apart. They're on opposite sides of the carbon-carbon double bond. This is on the top. This is on the bottom. In this molecule right here, our functional groups are on the same side. So when our functional groups are on different sides, we could call it trans. We could call it trans, literally for, I believe, Latin for apart, or Latin for opposite. I'm not a Latin scholar, so forgive me. But the functional groups are apart, so we call it transbutene. The other convention to use comes from the German for apart, and there we call it Entgegen. And instead of writing out Entgegen, we write E in parentheses. So we would call, let me do this in different colors since this molecule down here is blue. So we would call this E-butene. These mean the same thing, E-butene. But this is now kind of the standard convention. We'll see this notation where you use Entgegen, or E, is actually more powerful. It can extend to when we have more than one functional group on each carbon. So let me just make it clear that the E stands for Entgegen. Entgegen, which is German for apart. Or at least I believe it is. I can't speak German, so I'll just have to take people's words for it. Now, in this situation where our functional groups are on the same side, you could call this cis-butene. Cis, I believe, comes from the Latin for together. Or you could call it Z. Or you could call it Z-butene. Butene, and you could imagine this Z comes from the German for together, and it stands for zusammen. Zusammen. Zusammen, which is German for together. And that's all you have to do. And in the next few videos, we'll do a bunch of examples here so we can really figure out whether to label something with either an E or a Z. But I wanted to expose you to the cis and trans naming scheme because that's sometimes used for simpler molecules where you only have one functional group on each side. But I want you to realize that they're really trying to make the same differentiation. They're really just trying to decide whether the functional groups on one side of a double bond and on the other side of a double bond, whether they're on the same side, cis, or Z or zusammen, or on different sides, trans or E or Entgegen.